Okay, so polar coordinates are totally different than rectangular coordinates. The only thing that's the same about them is just that it takes two coordinates to do it, but the two coordinates are totally different than x and y. The two coordinates that you have are r and theta, and so this is very closely related to trigonometry. So polar coordinates are based on the distance from the pole, so we call the origin the pole. Okay, so the pole is what we call the origin. So it's kind of like you're looking down on the Earth. Think of like this is like the North Pole, okay? It's the center, right? And so these are all the latitude lines. And then these will be the longitude lines. So the pole is the center, okay? And then the other coordinate, or sorry, and then the distance from the pole as a function of the angle theta. So distance from the pole is called r. And then it's in the direction of theta. Which is the standard trig angle. So your two coordinates are how far away from the pole you are, how far away from the origin, and at what angle. So this means, so positive and negative being left, so positive being to the right or positive being up is thrown out the window. The positive direction is always the direction of theta. So that could be any direction, right? So I'm showing that with a black line, okay? So do you see the black line? Let's see if this is not going to be too fast. That's good. Okay? So the black line could, any direction could be a positive r. And that direction is determined by theta, your counterclockwise angle swept from the x-axis. So here is what? Pretty close to, what is that? No. So this is pretty close to 2 pi over 3, okay? This is pretty close to the angle 2 pi over 3. So what's the direction of positive r? The direction of positive r is along the ray that's at the angle 2 pi over 3. So for instance, the point, so r theta, 3, let's say 4, comma, 2 pi over 3. So polar coordinates are given as r comma theta, but you really think about theta first. So rectangular coordinates were x comma y, and you think about x first, right? You go x and then y. Well, it's kind of backwards with polar. It's like you give them as r comma theta, but you really do theta first. So you get your direction, and once you have your direction, which is I'm kind of showing here as 2 pi over 3, then positive r is in the direction of that black line, 2 pi over 3.
Where are you getting 4 here?
I made it up.
Oh, okay.
Just made up this example of this ordered pair 4 comma 2 pi over 3. So where would 4 2 pi over 3 be? So in the direction of 2 pi over 3, you're going to go a distance of 4 away from the pole. So precisely, so this angle isn't quite 2 pi over 3, but this lighter line is, right? So that's that point right there. So a positive r value can be in any direction from the pole. It's not necessarily right, and it's not necessarily up. Do you see? It can be in any direction from the pole. So then what's a negative value of r? So what would be negative 2, in blue, what would negative 2 pi over 3 be? Where would that be?
It would be on the red line.
Right. So in the other direction from 2 pi over 3, 100 pi radians away, or going backwards. So when you set 2 pi over 3 as your angle, now here's your positive axis, and here's your negative axis. So that point would be right here. That's the point, -2, comma 2 pi over 3. Does it make sense?
So they have to be in. You have to know. Oh, never mind. I got it.
So the angle sets the direction of positive r. Negative r will be backwards from the pole from that. So polar curves, therefore, have the form r as a function of theta. Like I said, theta comes first, right? So for given values of theta, so you have some relationship where for different values of theta, you get different r's. So let me give you an example here. And this is eventually what we want to work towards is given so here's a polar function, e to the sine theta minus 2 cosine of 4 theta. R is, so f of theta is r. F of theta is the distance from the pole, and that's as a function of what your value of theta is. So as theta changes, r changes, and you're going to get a curve, right? And so our goal is to be able to sketch these curves. Now, this one's really hard, but it's kind of fun. So here we go. Ready? So as theta increases, you get different values of r for every value of theta, and that sweeps out a curve. So right now, theta is about almost pi over 2, right? So here theta is almost pi over 2. And as theta changed from 0 to pi over 2, we got all the corresponding r values made this loop, or the start of a loop. And now theta is going from pi over 2 to pi. And now from theta goes from pi over 2 to 3 pi over 2. And see, it's graphing in positive and negative territory depending on what theta is, right? Sometimes the output of the function is negative, so it's going to be graphing on the red line. But sometimes it's positive, so it's graphing on the black line. But as you keep going around here, so this particular function makes a butterfly. Isn't that cool? Or yes, or orbitals, right? Okay. So we're not going to do ones that hard, but the goal is that we'd be able to graph some simple polar functions. We'll work hard on that, but those can get tricky. But we got to think about, rather than how does y change. So how does y change as you move from left to right? That's what we've been doing all our career, right? Now it's how does distance from the pole change as theta changes, right? Okay, so let's just do some. So let's talk about, say, the point I'm trying here. So what about this? This is 5 or 6, say 5, right here. So this is the point of 5, comma, pi over 6. Right. Okay, so what are the x and y coordinates of that point? So if we wanted to find out what It's kind of like if we superimpose the polar plane, which is this like radial plane, with the Cartesian plane, where would that point lie? What would the x and y coordinates be? And I'm not saying estimate, right? So I'm not saying estimate. So what? I want to get it exactly. So this angle is pi over 6 is our theta, right? And then there's distance here is 5. So we sweep pi over 6. Now we have our distance of positive, we have our direction of positive r. I'm going to go out 5, and that gives me the point 5, 5 or 6. Well, what are the x and y coordinates of that point? Okay, not an estimate. I want exact expressions for that point. What's that?
The y would be 5 sine pi.
Okay. So the y coordinate would be like this distance right here, right? And then the x coordinate would be this distance right here. So it should be conjuring up something from your.
Sine pi.
Yeah, so this is gonna be trigonometry, right? It's gonna be trigonometry to get these x and y coordinates. So the x coordinate would be 5 cosine theta, right? Or 5 cosine pi over 6. And the y coordinate would be? And so you're saying that 5 cosine pi over 6 should be something like around 4.5. And 5 sine pi over 6 should be something like 2 point something. Let's see. There we go. So 5 cosine pi over 6 is 4.333. And 5 sine pi over 6 is 2.5. Okay, so then this is going to be important. Given a pair of coordinates and polar coordinates, what are the corresponding Cartesian coordinates or rectangular coordinates? And so we'll be like kind of living in both a lot simultaneously, having the planes superimposed on each other and working back and forth between the two. So given any angle theta, so this is just any generic angle theta here, and any distance from the pole. So this is any point now, r comma theta. Not necessarily where I put it. It could be anything. So any theta and any distance r. What are the x and y coordinates at that point? Hemming's got it. So the x coordinate would be r cosine theta and r sine of theta. Okay, it's not for just this point that I've drawn. For what points is this true? Every point you're looking at in the plane there. Okay, so these relationships are key. So burn them in your brain right now, forever and ever. They're going to come. So as you're working with these polar graphs and polar functions and the polar plane, this is bedrock. Okay. Whenever you're kind of transitioning and working in both systems at once, we've superimposed the Cartesian plane on top of the polar plane. Here's the relationship between x and y and r and theta, or one way to do that. So now what about the other way around? What if I know x and y, and I want to find r and theta? So, did you put stars on your notebook in your notes? Okay. Make sure you put stars in your notes. Okay. All right, here we go. Because I'm erasing. So now I've got some other point. Okay, there. Okay, so now here's this point out here, and I know x and y, and I want to know the corresponding r and theta. How about that?
X divided by arc cosine of x over r.
That's pretty bad. So here's, I know x, and I know y. The question is, what is r? So r is easier. So what would r be? Ruth's got it. She's getting there. What would it be? Jacob, did you get it? What would r be? So if we knew x and y and we wanted to find r, you could do it.
Solve for r.
Yeah, given x and y. Joseph.
Is it the Pythagorean theorem?
It is. So what would it be? R equals?
R equals the square root of x squared plus y squared.
Okay. And what now, given x and y, what would theta be? Hunter was kind of on top of that one. What's that going to be?
You can just kind of take the reverse of how we solved it. So it's just x over r, arc cosine of that.
But we need it in terms of x and y. Can't use r.
So x divided by square root of x squared plus y squared, arc cosine of that entire thing.
Okay, so there's an, all right, that works. There's an easier way. If we just use x and y, so relative to theta, we got what, opposite side and adjacent side. So rather than arc cosine, so opposite and adjacent. Tangent. So tangent of theta is y over x, right? So theta is inverse tangent of y over x. Now remember, the range of arctangent is from negative pi over 2 to pi over 2. But there's a lot more angles than that, so you got to adjust where needed. So adjust where needed. Your output of arctangent will always be a number between negative pi over 2 and pi over 2, corresponding to the angle that you need. You might have to adjust. Add pi, subtract from 2 pi, something like that. Okay, so this is given x and y, how you'd find r and theta. Given r and theta, this is how you'd find x and y. Again, key relationships that are true for every point in the plane. For every point in the plane and every problem you're going to do where you're transferring between polar and rectangular coordinates. Okay, so let's practice a little bit, some finding points and things. Questions on this so far? Oh, and so what about negative angles? So if theta, we talked about r being negative, that means you go in the opposite direction backwards from the angle that you're at. What about theta being negative? Just like trigonometry, right? A negative angle would sweep clockwise from 3 o'clock. Okay, so I want you to plot these. And part C, I want you to figure out 3 other ways to express that same point in the plane. Okay, so work together on these. I'm going to do something different here.
it's
the
like
part about.
2
I know
negative
it's a
pi.
cool on, but that's where the like part is.
It's not really gonna make it easier.
Yeah,
So
so
I
much
just think
stretches.
I don't know why that's this.
Did you get this? It's cosine of pi, sine of pi, which is negative 1, 0. And then 2 cosine of negative 2 pi over 3, 2 sine negative 2 pi over 3, and then negative 3 cosine of 3 pi over 4, and negative 3 sine of 3 pi over 4.
Then do it again.
The second one, plot the points.
Yeah.
Okay, so did you get the coordinates of the 3 points for number 1? Did you plot them correctly? Put them up there. Agree with that?
Yep.
Okay, and the xy coordinates of 1 comma pi? And how did you get that?
X equals cosine pi. Y equals sine pi.
Wah, 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 wah. What point is that?
It's in negative 1, 0,
And how did you get that?
by just using.
Looking at it.
No, by getting that x is equal to r.
No, you just look at it. You're 1 unit along the negative axis, right? You're 1 unit to the left. And you just say, it's negative 1, 0. You don't do cosine theta and sine theta, right? You see what I'm saying? That's what I meant, by easiest way possible. If you know where that point is, you go to the negative x-axis and then you go 1. That's the point, negative 1, 0. So xy is negative 1, 0. So yeah, of course it works if you do the r cosine theta, r sine theta. It absolutely works. But that's not very efficient. Okay. How about this last point then? So then these others, yes, you're going to do r cosine theta, r sine theta. So, but when you end up on the axes, then those points you can get those points without cosine and sine. All right. So this last point is negative 7 pi over 6. What quadrant does that put me in? Negative 7 pi over 6. So here, third and second. Is it third quadrant or second quadrant?
Second.
Second quadrant, okay? Because negative 7 pi over 6. So 6 pi over 6 would be back to the halfway around the circle. And we're going to go another pi over 6. And we want to go to 4. So where's that? Is that here? Is this point? So this is the point 4 comma negative 7 pi over 6. So there's only one way to write that point with x and y. There's only one x coordinate that it has and only one y coordinate that it has. But with polar coordinates, how many ways could we express that point in polar coordinates?
Countless.
What's that?
Countless.
Yeah, the countless, because we could go around here, you know.
At least times.
Yeah, so we can go around here, and then I could just add 2 pi, right? And it would take me back to the same place. Okay, so what's another way to express this point then? So we could go negative 7 pi over 6 this way, and then out 4. What would be another way to use r and theta to get those points, that point?
5 pi over 6, 4, 5.
So you want to do the angle 5 pi over 6? And then what would it be? So 5 pi over 6 and
4
How about another way?
Do negative 5 over 6 and negative 4.
Negative pi over 6 would take you here, and then negative 4. What do you guys think about that? So negative 4 and negative pi over 6. One more way. Someone got something different than that.
4 negative 9 pi over 6.
So negative 9 pi over 6. I think that negative 9 pi over 6 takes you, that's 3 pi over 2. Is it?
Well, I was thinking 2 pi would do another full rotation plus the 7 pi over 6 again.
No, but
That would be negative
but 9 pi over 6 is only adding 2 pi over 6. It's not adding 2
Oh,
pi.
yeah, excuse me, 14 pi over 6.
Okay, so
Negative 14
4. So you're basically saying minus 7 pi over 6 minus another 2 pi.
pi. Correct.
So basically what you're saying. So we just write it that way. That's fine. Yeah, so go negative 7 pi over 6 and then go another 2 pi around. Okay, get the picture? So there's, and we do the same thing with this. We could do 4 and what? 5 pi over 6 plus any multiple of 2 pi. So I can say like 2 pi k. So any integer. That's how we get an infinite number of ways to write this point. I could keep going around, keep adding 2 pi to 5 pi over 6. It takes me back to that same angle. Go 4 out, and you got the same point. Okay, questions on that? What's that? Integer? So any multiple of 2 pi. This is the idea is any multiple of 2 pi added to 5 pi over 6 takes you in that same angle direction. Okay, so let's do all that. So let's start working on then graphing polar functions. So we really have to have a good sense of the polar plane, like how we get the points, like we just did. So now we're going to start graphing functions. So let's look at f of theta equals 2 sine theta. So the way that we do these is we need to get the relationship of r and theta. So where's r? Where do we see r here? So r is determined by what theta is. So it's the idea of a function. So given a value of theta, we have a corresponding value of r according to 2 sine theta. So as theta changes, r changes, and we get a set of points, right? Set of points, just like x and y functions, but now in the polar system. Okay, so what we need is this relationship between r and theta. So we're going to get that by graphing 2 sine theta in the rectangular plane. So we get this relationship. We have a visual on the relationship between r and theta. And we're going to transfer that into polar coordinates. So could you sketch r equals 2 sine theta? Could you sketch that in rectangular coordinates with theta being your horizontal coordinate and r being your vertical coordinate? Could you sketch it from your past math experience? Can you tell me one thing about what we'd be graphing, the resulting graph? Can you tell me one thing? Start with 0. Okay. And how high will this go?
Go to 2.
2, 2. Yeah, because you're multiplying times 2.
And how low will it go? Right, so it's our basic sine curve, but it's going to be magnified by 2. How can we start structuring what's going to happen on the x-axis? So when we sketch this, how do we think about?
It's still going to equal 0 at pi and at 2 pi.
So we're talking about pi and 2 pi. And then what happens after 2 pi?
Rinse and repeat.
It repeats, right? It's going to start over. Now, so these repeat too. These polar graphs repeat too, but sometimes they don't repeat at the same period that this graph does, and we'll see that. So sometimes we might have to like extend and go farther, like go draw 2 cycles in order to get the entire polar graph, or maybe only half of the cycle will get us the whole polar graph, or maybe it is the same as the cycle of the graph we're about to sketch. But so just be aware of that the period here is not always the period of the polar graph. Okay, so what's going to happen now? So what's this going to look like? So when you sketch these graphs, you really break the period up into 4 pieces, right? These waves are kind of broken up into 4 pieces. So for this particular one, the period's 2 pi. So we're going to go from, so we got pi over 2, pi, 3 pi over 2, and 2 pi. And we've got a minimum, a midline, and a maximum. And where does sine start at the beginning of its cycle? At the minimum, the midline, or the maximum? He said midline. Agree? And then it goes down to the min or up to the max? To the max, and it's not a straight line, right? And then back to the midline, and then down to the min. So that one's pretty easy, but we're going to have to brush up on slightly more complicated, like, and we'll see more, but could you sketch, -3 cosine of 2 theta plus 1? We got to be able to, we'll practice, but you have to be able to sketch these in the rectangular coordinates, sketch the wave, in order to learn how to draw these polar graphs. But we'll get to the harder one. So let's still work on this one. But I just want to give you a heads up. We got to know how to sketch the transformations of the sine and cosine graphs. Okay. Did you have a question? All right. So here we go. So what we're going to do is we're going to use that graph that we just drew to draw the polar graph. Okay. And we have to. What we're going to think about is theta varying over intervals. As theta varies over an interval, we're going to look at what r does, and we're going to track. We're going to track all the points as r changes for the current value of as theta changes. Let's see if we can get a point on here. Let's see. Oh, no. Okay, hopefully that'll work. All right, so what are we starting with? We're doing 2 sine theta, right? So we're going to look at theta varying through intervals, and then look at our graph to tell us what r does. So what's the first interval we want to look at? As as theta goes from 0 to pi over 2, what does r go from? From what to what? As theta goes from 0 to pi over 2, r goes from what to what? 0 to 2. So let's plot that starting and ending point, right? So what's the starting point? So it's the point theta equals 0, r equals 0. Where's that? Yeah, anytime that r equals 0, it doesn't matter what theta is, you're going to get the pole, right? You're going to get the pole. So we're going to start with that point right there. And then the final point is at pi over 2, r equals, what are the coordinates of that point? Say in x and y. So pi over 2 comma 2. What would it be, Haley? The coordinates of the point, if the polar coordinates are 2 comma pi over 2, that's what we're talking about, this 2 comma pi over 2. Yeah, so our angle is pi over 2, and we're going to go up 2, so that coordinates are 0, 2, right? 0, 2, and x and y. But in between, what? R increases from 0 to 2. So hopefully my point, I just want to plot the point, not the curve yet. So let's see, hopefully this works. It doesn't. Let's try it this way. So what would x equal? It would equal r cosine theta, right? This way. And y would equal r sine theta. See what I did? So what is this going to do? As theta changes, oh, but it's going to be n. So n is how I vary down here at the bottom of the screen. It's how I vary the angle measure. So n stands for the angle measure, and it's how I vary it. Okay, this should work. All right, so watch. So as theta goes from 0 to pi over 2, watch what happens. Yeah, good, it worked. See this? R is increasing from, did you see it? This is really important. So as we increase in the angle, it just, that the point gets further and further. It goes from 0 to 2. So if we're sketching that, it's like, okay, we imagine the angle turning this way, and we're coming out farther and farther away from the, and like that. Is that about what it did? Not bad. See that? Okay, so then as the angle changes from pi over 2 to pi, what does the r value do? Looking at our graph then.
It goes back down to 0.
Goes back to 0. So what will that look like? So as the angle, I want to turn that off in a moment here. So as you go from pi over 2 to pi, imagine that point, or that r value decreasing back to 0 again. What will it look like? You said it looked like a mirror of the first thing. Yeah, exactly. So let me turn it on and show you. Turn on that point. See it? Okay, so sketching that. So we imagine as we turn this angle that r is gonna decrease, right? So we'll do separate points here like this. So each time we increase the angle, it decreases like this. So something like that. Okay, what about as theta changes from pi to 3 pi over 2? Turn it off. So as theta changes from pi to 3 pi over 2, Now what's our value of r?
Negative.
What to what? 0 to negative 2. So what quadrant would that plot out in?
First.
We're going from pi to 3 pi over 2, but our r values are negative. So that's going to plot in the first quadrant where the red. See, this is negative r's now, so it's going to be where the red is. And it's going to go from what to what? 0 to negative 2. And what will happen? It's going to trace the same points again in the first quadrant that it did before. Watch it. Here we go. Ready? Uh-oh. Someone's not happy here. Let's try it. Maybe it works. Yeah. I got stuck, but you can see the point, right? It's going to trace the same points again. And then as you go from 3 pi over 2 to 2 pi, r will go from negative 2 to 0. What quadrant will that plot in? Second quadrant for negative r. And we'll, again, just retrace what we already did. All the negative r values in the sweeping through the fourth quadrant. So this is what I was talking about. So even though the period of 2 sine theta is 2 pi, in this particular problem, it only takes pi to get the whole polar graph, because the second half you repeat it again. See that? So sometimes it takes 2 cycles on your original graph to get the whole polar graph. Here it only took half a cycle to get the whole polar graph. So then the question is, what is this? What is this thing? So maybe it's a circle, right? So what I drew was pretty good in terms of where that black dot is going. See that black dot? So is it a circle? So how can we prove it? Can we prove that it's a circle?
Can we prove it using the sketch of 2 sine?
Not using the sketch. So proving it means that we're going to use mathematical deduction to show that that would be the same as the equation of a circle. So how can we do it? We got r equals we know that for sure, right? And somehow we want to say, hey, this is a circle. And what circle might we think it is? What circle is? Radius of 1. Center of? Radius of 1. Center 0, 1. So what is this? So to show that that is indeed that circle, it's going to mean a matter of taking this r equals 2 sine theta and doing what to it? But I'm not talking about what's the first step. I'm talking about what in general will we do? What is it? What will our goal be to prove that this is the same thing as this circle? What's that?
Get the function of the circle.
In terms of?
X and y.
Right. So we want to get the equivalent relationship of x and y to this.
That's why.
Is this y? Almost. We really like what? What is y equal to?
R sine theta.
R sine theta. So it'd really be nice if we had an r there. Well, we have an equation, so what does that equal?
Y.
2y.
2y.
No. Oh, yeah, yes, you're right. It does equal 2y. But we can't just go take expressions and multiply them by r. We've got an equation, right? So we just change the value of this, but we can maintain the equality, right? How do we maintain the equality? Okay, which is? Squared. So now that's nice because now on the right we have, like you said, 2y. And what's r squared? Piece of cake. No, r is a variable, right? R is changing for different thetas. No, what is our goal, you guys? What is our goal?
Or sine squared theta.
No. What is our goal? What are we trying to do here? Get the equation of, in terms of x and y. X and y. So we don't want thetas. We don't want r's anymore. We want to get x and y.
If R is 1,
X and y. X and y.
Squared plus y squared.
Right. Isn't r squared equal to x squared plus, because r is the square root of x squared plus y squared? We got that relationship, the triangle relationship? Make sense? Okay, getting closer. So what do we want? We're trying to get what? We're trying to get the equation of circles. We're going to move this 2y over, right? X squared minus. Okay, so what do we need to do? We want what? Y minus something squared. So we need to complete the square on y. We need to complete the square. We've got the first two terms, the quadratic and the linear. We need to complete the square so that we get something squared, right? So what completes the square? Half of this coefficient squared. Remember that? You take half of the coefficient of y, square it, and add that on. So what is that? Half of negative 2 is? Squared is? 1. And equals? Not 0. You can't just add 1 to one side of the equation.
One.
Got to add 1 to both sides. So then we get x squared equals, or x squared plus, here's our perfect square, y minus 1 squared equals, radius of this circle is, center is, see? That's what we thought. So here's the math that proves it, right? So this is what we just showed, is that r equals 2 sine theta is equivalent to x squared plus y minus 1 squared equals 1, or the circle with center 0, 1 and radius 1. So we've accomplished a lot here. Okay, we practiced. We got our first polar function. We sketched it in the Cartesian plane. That allows us to sketch it in the polar plane. We thought, hey, maybe that's this circle. So we went back to the equation, and we showed mathematically by changing this into x and y that it is indeed the circle we thought it was. Question? But that involved completing the square, right? So we had to know how to complete the square. Half of your coefficient of y squared gave us 1. Half of the coefficient of the linear term squared completes the square. But then if we add it to the left, we got to add to the right. Okay, another example. Any questions on this? So let's try, you guys try 1 minus cosine theta. So sketch. I'm going to sketch it this way. And then you're going to use this sketch to sketch it in the polar plane. So you guys see how much progress you can make. See how far you can get want to sketch that. Sketch that in with theta as a horizontal coordinate and r as the vertical coordinate. Then use your sketch and intervals of theta to sketch it in the polar plane. Okay, hopefully we got this graph by now. Where does it start?
Zero.
At 0? And then? So where's the midline?
1.
Yeah, the midline's at 1. And what's the max? The max is -1. The midline's at 1 and the max is at -1. Does that make sense?
2.
Max is above the midline, right? So we're shifting it up 1, right? Cosine goes from -1 to 1. We're shifting it up 1. So that's going to be from what to what? 0 to 2. Okay, and then we're basically going to have cosine, but it's going to be flipped upside down. So we're going to have cosine in this 0 to 2 range, right? But flipped upside down, so that's going to start at 0, and then head up to the midline, then up to the max, and then back down to the midline, and then like this. Job out of the hut. Okay, did we get that? So did we have success graphing that? Hopefully. And so now we're going to use that to sketch our graph of the polar graph.
Why is the midline at 1?
Because you're moving it up 1, right? So normally it's 0, so this is like adding 1, right? Okay, so then as we go from 0 to pi over 2, oops, something's drawing here, something. What's drawing here? Turn this off. Okay, so as we go from 0 to pi over 2, r goes from what to what?
From 0 to 1.
0 to 1. So imagine r increasing. So watch that black line. Imagine r increasing as that angle goes from 0 to pi over 2. So r is increasing. Think about it. As we increase in theta, we're going to get r is going to go from 0 to 1. Okay? And then from pi over 2 to pi, r goes from 1 to 2. So it continues to increase until it gets out to 2. So kind of follow a point on the line. Increasing from 1, increasing from right here. As it turns, increasing out to there. So can you imagine that? It'd be something like this. Increasing, 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 out to 2, positive 2. So let's see how I did. Not great, but something. So watch the point. Okay, I was way too far out there. And not far enough. So I'll sketch it again. But so increasing r goes to through 1 pi over 2, and then 2 pi. And then what happens on the back half here? Back to 1, back to 0. Back to 1, back to 0. So it's going to be, see that it'll be the mirror image of what we had above? So decreasing, R is decreasing, back from 2 to 1. Is this negative 1 or 1 right here? Is this negative 1 or 1 right here? Positive 1. When the angle is 3 pi over 2, positive direction is straight down. So that's positive 1, and then back to 0. Let's just turn it all on here. So what, 1 minus cosine function on. Here we go. Ready? So there's R increasing from 0 to 1, and then from 1 to 2, and then from 2 back to 1, back to 0. So this is called a cardioid. Cardioid, root for what? Heart, right? Heart. Because it's like a heart kind of on its side. So that's a cardioid. Okay, so those are easy ones. So this doesn't have a, this doesn't have a nice slick. We have never really seen that shape in terms of x and y, the relationship of x and y. So if we were to try to write this r equals 1 minus cosine theta as a relationship of x and y, things might get messy. Why? Because this isn't a shape that we see in rectangular coordinates. Okay. But that circle was, and so with that circle, we saw that with a few simple changes from the given equation into x and y, we could get that equation of that circle. But cardioids, we've never seen cardioids before. They don't lend themselves to x and y nicely, so we're not even going to try. Okay. All right, we need a harder example. So questions on sketching these polar graphs. So how about this one? Something harder. Uh-oh. Okay, so first of all, can you sketch that as a wave, like theta horizontal axis, r on the vertical axis? So here's this kind of a general strategy for graphing these. 1, find the midline. That's the horizontal center of the wave. Okay. Next, find the max and min. So we get our horizontal channel where this thing is going to live, right? The midline and the max and the min. Third, figure out what the period is. And then a period is broken up into how many parts to sketch the wave? 4 parts, right? So it's always broken up into 4 parts. So the period and then quarter periods along the midline or along the horizontal axis. And then you look at, is it sine, cosine, negative sine, negative cosine? You've got your horizontal channel, right? You got your horizontal channel now, and you've got your 4 parts of the wave. So now it's just a matter of sketching the right curve. Sine starts at the midline, goes up, back to the midline, and then down. Cosine starts at the max, midline, min, midline, max. So sketch your midline, figure out what your max and min are, Oh, this is not what I want. Sorry. Hold on a sec. No, yes, this is what I wanted. This is what I wanted. So the period of sine is what? What's this period of plane sine? 2 pi. So we need 2 theta to reach what? 2 pi. When 2 theta reaches 2 pi, that will give us a period. So what value of theta makes 2 theta reach 2 pi? That's what we're asking. That's the period. Value of theta that makes the argument reach 2 pi is pi. So when theta hits pi, that thing hits 2 pi, and we just got to start over with sine, right? So you're going to take your argument and set it equal to 2 pi. And that's going to be that's the angle that you need for that thing to reach 2 pi, which will then give us the period. Does it help? Cycles of this. So sine starts min, midline, or max? Midline, and goes where from there? In the first quarter cycle. Up to 5. So it's going to go from 2 to 5. Then back to 2 at, what is that? Pi over 2. Then at 3 pi over 4, it's going to go to -1. And then back to pi. And it's going to repeat that again as you go from pi to 2 pi. So at 5 pi over 4, up to 5, 6 pi over 4, back to 2, 7 pi over 4 down to -1, and then at 2 pi back to 2. So here's that blue graph is the one we got to transfer into polar coordinates now. So before we were going from 0 to pi over 2, our intervals, but now we need to go from 0 to pi over 4. So as you go from 0 to pi over 4, what does the radius do? R goes from what to what? So we're going to go from 0 to pi over 4. And it goes from what to what? Nope, not 0 to 2. 2 to 5. So at theta equals 0, we're going to start at radius equals 2. And then by the time we get to pi over 4, we're at 5. Here. So imagine what? The radius increasing as theta increases from 0 to pi over 4. So let's look at that. So imagine the radius increasing. So you have to do that without the, without the grapher. So you have to see that that's going to, R is going to increase from 2 to 5 as theta goes from 0 to pi over 2. Just try to sketch it here. Sketch what I saw. Something like that. Okay, and then as we go from pi over 4 to pi over 2, what happens? R goes back to 2. So it's going to be kind of like a symmetric. So as the angle increases to pi over 2, imagine that R decreasing to 2. Why did it start at 2?
Because when the angle is 0, the function is equal to 2.
Yeah, see? So it's gonna decrease back to 2 the way it increased in the first pi over 4. So back to something like that. Okay, then from pi over 2 to 3 pi over 4, what's going to happen? Goes to -1. So somewhere in there, it's going to go to 0. Okay, so somewhere in there, that thing it's going to hit 0. So and what is that? That means that at some angle between pi over 2 and 3 pi over 4, it's going to decrease and it's going to get to 0, and then by the time we get to 3 pi over 4, it's going to be at negative 1. So let's plot that point, negative 1. So at 3 pi over 4, for some reason I don't have the circle 1, but I can estimate it. 3 pi over 4 is going to be at negative 1 like this. Somewhere it's going to cross through the pole because r will be 0. So what's this going to be like? It's going to decrease rapidly to 0. And then go to negative 1 like that. And then from, where are we at now? From 3 pi over 4 to pi, it's going to go back from negative 1 to 2. So at pi, it's going to be at 2, which is here. So it's going to undo what it just did. It's going to go back through the pole. It's going to be a little loop there. And then it's going to increase out to 2. So let's see if we follow the point here, if it does it. So go through 0, out to negative 1, negative 1, and back to 2. So I did pretty good. So 2 to 5 to 2, through 0 to negative 1, back through 0 to positive 2. And that's the first cycle. But so we need another cycle of that f to graph the rest of it. So what's it going to do? It's going to do the same thing. It's going to go 2 to 5, back to 2 to negative 1 to 2. So it's going to retrace this whole thing, but now starting at pi through the third and fourth quadrants. So at 5 pi over 4, it's going to be out at 5. I'm such a what?
I just keep drawing it. I can't.
Oh.
Right. Sorry.
Yeah, the drawings are hard. So that's, I mean, yeah. So do your best. This is not, be graded on your artistry, but it's hard. You're right. It's hard. All right. So then from 2 to 5 first. Back to 2 at 3 pi over 2, right? We're back to 2 here at 3 pi over 2. And then in the next quarter pi, we're going to get all the way to negative 1 through 0 again. So it's going to go 0 and then negative 1 at 7 pi over 4. Something like that. And then back through 0 and out to 2. Anyone get it before I drew it?
I didn't get the little loops. I had them as lines, kind of like the smaller loops.
So the smaller loops are where r is in negative territory, right? That's where r goes out to negative 1 and back, so through 0, out to negative 1 and back. All right, so let's see how your teacher did. Here we go. Let's turn it on. Here it goes, ready? 2 out to 5, back to 2, through 0 to negative 1, back through 0 to positive 2, out to 5, back to 2, through 0 to negative 1, back to 2. Okay, so questions on the gist. So you got to know how to graph things like this, and there'll be like a no calculator portion of the final. So you have to sine or cosine, and cosine also, plus or minus. So I'm going to give you, over the weekend, you're going to have there's going to be a written packet. Actually, the written packet is part of kind of the review packet for the final. Stuff on, and I'll assign the stuff on Polar kind of as homework for Monday. And you've been doing lots of this, sketching the waves first, and then using the waves to sketch the polar graph.